Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice about how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam MAS1 of the Casualty Actuarial Society, Modern Actuarial Statistics 1. You are given the following bridge systems: System X, System Y, and System Z. All three systems X, Y, and Z are built with independent and identical components P. The reliability of System I is denoted by Ri for I equal to X, Y, Z. Determine which of the following best describes the reliabilities of these systems, and we need to figure out the relationship of the reliabilities of the three. And here's the solution. Systems X and Y have the same failure rates, and System Z has a lower failure rate than X or Y, because Z is a parallel system which functions if any of the three components function. So this gives us answer D immediately. But if you want a formal argument, so if you want to do it formally, you can just argue as follows. Let us write P for the probability that component P functions. In the trivial case, when P is equal to 0, P is equal to 1, all three systems have the same reliability. In general, Rx is Ry is equal to P times 1 minus P squared. So it's 2P squared minus P cubed. And Rz is equal to 1 minus P cubed, because of the completely parallel nature of that one, while X and Y have two components in parallel and one in line with those two in parallel. Rz is equal to 1 minus P cubed, so it's 1 minus 3P plus 3P squared minus P cubed, so 3P minus 3P squared plus P cubed, and therefore Rz minus Rx is 3P minus 3P squared plus P cubed minus 2P squared minus P cubed. So it's 2P cubed minus 5P squared plus 3P, or P times 2P squared minus 5P plus 3, or 2P times P minus 1 times P minus 3 halves. The expression P minus 1 times P minus 3 halves is negative for P between 1 and 1 half, and positive for P less than 1, and for P greater than 1.5. In particular, for P between 0 and 1, which must be the case since P is a value of probability, the expression P minus 1 times P minus 3 halves, and therefore also Rz minus Rx, because this is multiplied by 2P, which is positive definitely. So Rz minus Rx is positive, and this implies that Rz is more than Rx, and Rz is greater than Ry as well. Rz is more than Rx, and it's equal to Ry. And that's answer D again, which you could just guess by looking at the graph. That's perfectly okay. Please remember, this is copyrighted material. The problem itself belongs to the Casualty Actuarial Society. The solution is mine. Good luck in your studies and good luck on the